Hi students, welcome to our physics channel Physics Star. Today we will discuss about the continuation of the chapter waves. Already I have done few lectures based on waves. Once please go through it. And today what we are going to discuss in waves, that is reflection and transmission of transverse waves. Okay, transverse or longitudinal, both progressive waves, reflection and transmission of waves. Okay, now let us start discussing about reflection and transmission of waves. So let us start discussing about reflection and transmission. Let us call it as refraction of waves. Usually you might have heard this word refraction and reflection in case of optics, right? Okay, but in case of waves, how to understand reflection and refraction of waves? Let us consider two different ropes. Okay, or else take one rope first of all. Take one rope, fix one end of the rope to a fixed support and hold the other end. What you have now, the one end of rope is in your hands and the other end of the rope is fixed now. It is fixed to one support. Now what you are doing, you need to give a jerk to it. Okay, now so that one pulse is generated, and that pulse it goes as long as the rope exists. The same pulse moves from hand to that fixed end. Am I right? Then afterwards, when it reaches that fixed end, what will happen? There are two different ways to discuss. One is fixed end and the other one is free end. So if there is a fixed end, then we will observe the reflection of that wave or reflection of that pulse. And if, okay, now in one way, if there is a free end, we can observe the reflection of pulse in other way. Okay, let us discuss how does the pulse or how does the wave reflect when there exists a fixed end and free end. Okay, so let us now start discussing about reflection first. See here, now what we are doing, we are taking a pulse here. Now this pulse is created in a rope. Okay, now, and this pulse is going along the length of the rope. Now what we are doing, we are tying one end of that rope to a fixed support. Now what is this? It is a fixed support. It's a fixed end. Now what will happen? See here, what will happen when it reaches it? When it reaches the fixed end? When it reaches the fixed end, simply we can say that, see, when this pulse comes to here, usually what is happening? At this point, there will be some molecule or there will be one particle in the rope. Am I right or not? Okay, now that particle may either pull the molecule or particle of that rigid support downwards. It tries to pull that rigid support in the downwards. But meanwhile, due to Newton's third law, that rigid support also pulls that in the opposite direction. It means if this wave or if this pulse pulls, if this pulse tries to pulls this particle downwards, okay, now particle means which particle? The particle in the rope is pulling the particle on the wall or on the rigid support. If it is pulling in the downward direction, similarly, the same particle on the wall or on the rigid support, it also pulls the particle in the rope in the upward direction. Okay, now there are two different particles there. One is rope particle and the other one is okay, now particle of that wall or rigid support. Both are fighting now. If you pull me, I will also pull you, right? See, if it pulls downwards, then the another particle pulls that upwards. So when it pulls upwards, then what will happen? Then what will happen? The same pulse you will get like this. Means, how are you getting? You are getting that same pulse in reverse. Am I right or not? You are getting the same pulse in reverse. But do you observe? Can you say the amplitude of this pulse? If this amplitude of pulse is AI, let us consider, and the amplitude of this pulse is AR, then can we say that the amplitudes of these two are same or different? Definitely amplitude of incident pulse will not be same as that of amplitude of reflecting pulse. Not all the times, sometimes. Okay, now if there is a fixed end, amplitude may or may not be same. In which cases it may not be same, I will explain. Understand? Amplitudes may or may not be same here. Now, when are the amplitudes equal? Let me explain. See, first let us discuss about this. Now the same pulse is reversed and it travels in reverse direction, in opposite direction. It travels in the opposite direction. See what is happening when it reaches the fixed end, the same pulse get reversed and the same pulse is coming in the backward direction. This is what we call reflection. This phenomena is what we call reflection. Understand? Reflection. So this reflection of wave, during this reflection of wave from the fixed end, there will be a phase difference of pi here. If you want, you can observe here. At the wall, initially while it is incidenting at the wall, you may find it upwards. You will find that in upwards, but when it is reflecting back, it is downwards. You are going to find that amplitude in the downward direction, right? You are going to find that peak value of it, peak position of it in the downward direction. So it is getting reversed. It means that how much of phase difference you can find. The phase difference between these two will be the phase difference between the two waves. The two waves. What are those two waves? Incident and reflected waves. Okay, na? In case of this fixed end only is pi. Yes or no? It is pi. Reverse, completely reverse. Okay. This is pi. And if there is a free end, how do you observe a reflection of a wave? Okay, free end means now I am taking a reflection from the free end. Now, reflection from the free end. See here, if we consider a pulse which is generated in a rope, the same pulse travels along the length of the rope. Now, what I am going to do is, I am going to consider the end of that rope. At the end of that rope, I am just connecting this with a ring now. What do you observe? Here, I am connecting this other end with a ring now. Now the ring is able to move, or the ring is able to slide, okay, now on this wall. Assume this is a wall, okay, now, or on this, consider it is a rod. It's a fixed rod, and that ring is able to slide upwards and downwards very freely without any friction. Let us assume like that. Means it is a free end. This is what we call a free end. Okay now. So when in this situation, if a pulse is generated, this is what we call incident pulse or incident wave. If it is generated and if it is going with certain velocity and if it reaches to the end, then what will happen at that? See, when that reaches to this end, now the pulse will be created here. Yes or no? And meanwhile, if it is trying to come down, there is no other force which is trying to pull it up. Am I right or not? But initially it was not like that. There are two fixed supports. If one is pulling this in the downward and the other one is pulling this in the upward meanwhile, simultaneously. But here it is not like that. One end is completely free. It is able to move as its wish without any opposition, right? So it is directly coming down. It is directly coming down. Or else if this wave is passing through this, then this what will happen here, then this ring will come upwards first of all. Okay now, then this ring will come upwards and later, see here, if the pulse is coming like this, then the ring will move upwards and immediately it comes downwards. Got my point on it? The same wave passes through that ring also. If we assume that ring as a single particle, then the same wave passes through that ring also, so that the ring first moves upwards because it is free to move. Am I right or not? So first it moves upwards and later it moves in the downward direction. And later it moves in the downward direction. So that's why this ring will exert a force in the downward direction. Meanwhile, one reflecting pulse will be generated and this reflecting pulse travels in the opposite direction like this. See, do you observe any difference here and between in between fixed end and free end? Yes, definitely. In this free end, there is no phase difference at all. Am I right or not? Means previously the phase difference between these two waves, incident and reflecting waves, is pi. But here, initially the phase is same, and even while it is reflecting also the phase will be same. So this is a reflecting wave. Okay, reflecting wave. In this case, phase difference between incident and reflecting waves is 0. Okay, now what is the phase difference between incident and reflecting waves? Here it is 0. Okay, now similar thing we can apply to optics also. Suppose if we consider the light is traveling from rarer medium to denser medium, then we can say that, okay, the phase difference when it reflects back, the phase difference between the incident and the reflected ray, the phase difference between the incident wave and reflected wave is pi. When it is moving from, when light ray is incidenting from rarer medium to denser medium. But when it is incidenting or when it is moving from denser medium to rarer medium, then when it reflects back, then obviously the phase difference will be 0. So this is what happens in case of reflection, phase difference when it is reflected from the fixed end and when it is reflected from the free end. Now let us let us observe this mathematically. Consider one simple waveform here. Consider, now let us take one example. I am considering one waveform. Here y is equal to a sine omega t minus kx. A sine omega t minus kx. Now, what happens if this wave corresponds to that equation y is equal to a sine omega t minus kx? If this wave meets a fixed end, or else what happens when it meets a free end, and what happens when it meets a fixed end? Okay, now let us discuss about this. When it meets a free end and when it meets a fixed end, what will happen? Okay, see here. Now when it meets a free end, obviously phi is delta phi, phase difference is 0 here, and here it is delta phi will be pi. So from the free end, if it is reflected, we can write it as y is equal to a sine omega t plus kx. Why omega t plus kx? Do you know the difference between a sine omega t minus kx and a sine omega t plus kx? I have told this in the beginning of waves chapter. Once go through that. A sine omega t minus kx is there, then we can say that the wave is passing in positive x direction. If it is a sine omega t plus kx, then the wave is passing in negative x direction. Understand? Now, what is a phase difference? Phase difference is obviously 0, but only the thing which is changing is x. Initially it was negative, now it is positive. Initially the wave was passing in positive x direction, but now the wave is passing in negative x direction. Am I right or not? This is incidenting wave. Incidenting wave. Okay, now this is reflecting wave. And now let us see when it is meeting fixed end. Fixed end, when it meets, then what is the phase difference? Pi. So we can write this value, this equation as, this function as y is equal to a sine omega t minus kx plus pi. Omega t minus kx plus pi. See, sine 180 plus theta, omega t minus kx, you may call it as theta. So sine 180 plus theta, in which quadrant it is? Okay, 0, 90 minus theta is in first quadrant, 90 minus 90 plus theta, 180 minus theta is in second quadrant, third quadrant is 180 plus theta. Yes or no? But in the third quadrant, sine becomes negative, right? So therefore, y is equal to, you can write minus a sine omega t plus kx. Why plus? Because it is coming in the negative x direction. Yes or no? And what is the meaning of y is equal to minus a? Because amplitude is getting reversed. Phase difference of pi. Understand? Amplitude is getting reversed. Now let us discuss about the second example. Next example is y is equal to a sine. Consider the same function in different way. Omega t minus kx is there? No. Initially we have written omega t minus kx. Now let us write kx minus omega t. Kx minus omega t. Okay, now let us write kx minus omega t. In this situation, what is the meaning of it actually? Kx minus omega t. At time t is equal to 0, Okay, now if you observe, time t is equal to 0 means exactly when it is taken a photograph, time t is equal to 0 means, or else when it is starting from t is equal to 0 seconds, then you can say that a is equal to y is equal to a sin kx, y is equal to a sin kx, y is equal to a sin kx. Okay, minus here at time t is equal to 0, then you can write y is equal to minus a sin kx. A sin kx means what? Positive. You can get a graph like this. You can get a graph like this. Understand? Omega t minus kx means at time t is equal to 0, you can get a graph like this. Understand? This is the difference between these two functions, these two wave functions. Now, if we write like this, then if this is the incident wave, then from fixed end, or else sorry, from free end first, from free end, if it is reflected, then what is the wave equation now? How to write the wave equation? It is as simple as that. That is a sin kx plus omega t. Kx plus omega t. But here x is negative. Am I right or not? X is negative. So how to write this clearly? Let me write. See here, y is equal to let me write it clearly, a sin minus kx, because initially it was positive, now it will be negative, minus kx minus omega t. See here, what does it mean? Minus a sin kx plus omega t. Minus a sin kx plus omega t. Sin kx plus omega t means it is coming towards negative x direction, and minus sign does not indicate that the phase is reversed. It does not indicate like that. Okay. Here initially it was plus kx, now we are writing minus kx. That's it. It means that it is come in negative x direction. That is the only meaning of it. But if we consider the phase difference between these two incident and reflecting waves, then it will be always 0. It will be 0 here. Now let us take fixed end. Fixed end. What will be the wave function at the fixed end now? That is y is equal to a sin. Here a sin kx plus omega t only. But it should be in reverse. Am I right or not? It means it is quite opposite to free end. So what I have to write now? Y is equal to a sin kx plus omega t. Y is equal to a sin kx plus omega t. The difference between this and this, that is phase difference pi. See, if you just add plus pi here, then you will understand. You are going to get the same y is equal to a sin kx plus omega t. Am I right? So this is what we are going to observe in this. Y is equal to a sin kx minus omega t. Now the third one, y is equal to, let us take one more this function, wave function, then you will understand. Y is equal to a cos omega t minus kx. Y is equal to a cos omega t minus kx. Now this is a wave function which represents that at t is equal to 0, okay, t is equal to 0 means what? You are just taking a photograph of it. Means at a particular instant of time. Means you are keeping the t fixed. You are stopping that time. Okay, now, and you are observing the wave pattern. If you are observing that wave pattern like that, t is equal to 0, then you are going to get A cos minus kx means A cos kx, because cos of minus theta is cos theta. What does it mean? It means that at x is equal to 0, you are going to get a maximum value, okay na, at the starting position. So it moves like that. See, this is a wave function. Understand? Now let us discuss about this now. When this wave is reflected from free end, how to write the reflecting wave function? How to write the reflecting wave function? That is y is equal to a cos omega t plus kx. Now again, fixed end. Fixed end means for that we have to add plus pi. That's it. Free end is there? No. We have to add plus pi to that phase. Omega t plus kx plus pi. So cos 180 plus theta. What is cos 180 plus theta? That is also minus, because it is in third quadrant. Hence it will be minus. Therefore I am going to get y is equal to minus a cos omega t plus kx. Similarly, take the fourth one. Take one more thing. Y is equal to a cos kx minus omega t. This is a wave function. Now if it gets reflected from free end, what will be the wave function? Now you have to take x value. Initially here it is positive, but we need to take that as negative, so that y is equal to a cos of minus kx minus omega t. Cos of minus theta is nothing but what? Cos theta only, no? So therefore I am going to get a cos kx plus omega t when it gets reflected from the free end. And if it is a fixed end, again, how much is the phase difference here? It will be pi. Therefore I am going to get y is equal to minus a cos kx plus omega t. These are some examples in which you can observe how does a wave function change when it gets reflected from a fixed end and when it gets reflected from the free end. Understand? Now this is about the reflection of wave from fixed end and free end. Now let us discuss about what happens to two ropes. When there exist two ropes which are connected end to end, but one rope is a thicker rope and the other one is a thinner rope comparatively, then if a pulse is created or if a wave is created in one rope, when it tries to travel through the other rope, what will happen? Okay, consider two ropes. Now what am I taking? I am taking two ropes which are connected end to end, like series. End to end. There are two ropes which are connected end to end. Consider this is one rope. It's a thinner rope, and let us draw a thicker rope from here. Yes. See, this is a thicker rope. This is a thick rope. Yes or no? Yes. Now there are two ropes here. Now what we are doing is we are this is the point, this is the intersecting point of these two ropes. Now if a pulse is generated in this, understand, then it travels like this and it meets this rope. Am I right or not? Means when the same pulse is passing through this one, okay, now the same pulse will be passing through that other rope. Am I right or not? Because both are connected. So the pulse continuously passes. Okay, as long as it is the rope exists, the pulse travels. Yes or no? So when the pulse is traveling like this, what happens? What will happen initially? Let us discuss about that. See, in this case, just a minute. Yes. In this case, we have to assume this entire situation as the pulse is traveling from rarer medium to denser medium. We need to understand the situation as the pulse is traveling from rarer medium to denser medium. Means you can easily understand now, it is getting refracted when it is traveling from one rope to another rope, which is having a different density, density. Okay now. So then if v I is a velocity of incidenting wave. So when it reaches the denser medium, then the velocity of refracting wave or transmitting wave is Vt. Let us consider. Okay now, we can say that the velocity of refracting or transmitting wave is Vt. Okay now. Meanwhile, some portion of that wave will get reflected also. Usually when light incidents on one surface, which is separating two different media, two different optical media, what will happen? Two things will happen. One is either reflection or transmission, means refraction. Yes or no? So even here also, reflection occurs as well as refraction also occurs. Reflection occurs in which direction and what is the phase difference? Reflection occurs in the reverse direction, means if this is considered as origin, then this is a reflected wave. Why it is getting reflected in reverse? Why the phase difference is pi here? Here the phase difference between the incident and reflecting wave is pi only, right? So why is it pi? Because when it reaches this end, it acts like a fixed end. It acts like a fixed end. That's why it gets reflected in reverse. Phase difference is pi here. This is velocity of reflecting wave. In this situation, the amplitudes of incident wave, reflecting wave, transmitting wave, all are different. Okay. Now, assume that amplitude of incident wave is AI. What is AI? Amplitude of incident wave. And what is AR? Amplitude of reflecting wave. What is AT here? This is amplitude of transmitting wave. Amplitude of transmitting or refracting wave. Understand? Here we can say that amplitude of incident wave minus amplitude of reflecting wave is equal to amplitude of transmitting wave. Amplitude of incident wave minus amplitude of reflecting wave must be equal to that of, or okay na, or you can take plus. Okay na, while you are doing you have to take minus, is equal to amplitude of transmitting wave. Understand? Initially let us take plus here, AI plus AR, or else Consider directly. AI minus AR is equal to 80. This is about the relation between amplitude of incidenting wave and reflecting wave and transmitting wave. Okay, now when it is when the two ropes are connected end to end like this, when it is in reverse, it means suppose thicker rope is there initially, thick rope. This is a thick rope. Now this is the end of it, which is connected to thin rope. Now if a pulse is generated like this pulse travels with a certain initial velocity Vi. Then when it reaches to this end, it almost acts like a free end. When it is coming from thicker rope to thinner rope, it acts like a free end. When the same pulse is traveling from thinner rope to thicker rope, it acts like a fixed end. Reverse. So when it is like that, then after transmitting the wave will be like this, okay na, and after reflecting the wave will be like this only. Means in case of the pulse traveling from this denser medium to this rarer medium, then there is no phase difference between the incident and reflecting waves. Consider it is VR, reflecting velocity of or speed of reflecting wave. Here VT, speed of transmitting wave. Here you have to observe one thing. In both the cases, transmitting wave and incidenting wave both are in the same phase. Am I right or not? Transmitting wave and incidenting wave both are in the same phase. There is no phase difference between the transmission and incident wave. Yes? So this is what happens in two ropes when they are connected end to end. Now we are going to find the relation between amplitudes of incident wave and reflecting wave or reflected wave and transmission of wave and transmitted wave. We are also calling it as refracting wave. So relation between amplitudes of incident wave, reflected wave and transmitted wave. Now I am not going to say the derivation of this relations between incident and transmission or relation between incident and reflecting waves. Just I'll say the formulas because okay. Now let us discuss about the if once you go through the derivations you will understand very easily. Now I'll say just the formulas now. So here amplitude of reflecting wave is equal to V2 minus V1 by V1 plus V2 into AI. This is a relation between amplitude of incident wave and reflecting wave. And one more thing, relation between transmitted wave and incident wave, that is AT is equal to amplitude of transmitted wave is equal to 2V2 by V1 plus V2 into AI. 2V2 by V1 plus V2 into AI. What is V1? What is V2 here? What is V1? What is V2? V1 means incidenting wave speed of incidenting wave. V2 means, here let me write it, V1 means speed of incident wave. V2 means speed of reflecting wave. Understand? Speed of reflecting wave. Okay. I'm sorry, it is not speed of transmitting wave. I'm sorry. Transmitted wave. It means that simply we can say that speed in one rope is v1, speed in the next rope is v2. Simple. Okay, now in both the cases, let us analyze these formulas now. If v2 is greater than v1, what does it mean? It means that if a wave is propagating from one medium to another medium, one rope to another rope, okay, now what is happening? v2 is greater than v1. Velocity or speed is increasing. Speed is increasing. When does it happen? When it moves from denser medium to rarer medium. When it moves from denser medium to rarer medium. Yes or no? It means that what you have to understand, from denser medium to rarer medium means from thicker rope to thinner rope. Okay, so from denser medium to rarer medium, if it is going, then you can write the amplitude of reflected wave is positive. Yes or no? Because v2 minus v1, higher value minus lower value, you are getting positive value. Positive value means what? If AR is positive, what does it mean? It means that AR is positive means y direction. In y direction it is positive. It means that you can observe the phase difference as 0. You can observe the phase difference as 0 here. Understand? Phase difference is 0. Means you may understand it as free end. Means wave is meeting the free end now. Okay, now that is about it. Then if v1 is greater than v2, means starting velocity is greater, and when it is transmitting into other rope, its velocity becomes less. It means that the wave is propagating from rarer to denser. The wave is propagating from rarer to denser, so that AR becomes negative. Yes or no? Because v2 minus v1 is greater. That's why v2 minus v1 will give you negative value. Therefore, delta phi, what does it mean? A is negative. Amplitude of reflecting wave is negative. Therefore, delta phi is equal to pi. What does it mean? It means that it is reflecting from fixed end. Transmitted wave is not like that. Once observe, transmitted wave, whatever the v1 may be, whatever the v2 may be, irrespective of whether v1 is greater or whether v2 is greater, but transmitted wave is always positive. Am I right? So this is about the relation between the amplitudes of incident wave, reflected wave and transmitted wave. In the next lecture, I will explain I'll explain the problems in this. Okay. Once again, we will revise this concept, and I will explain the problems also. Right? Thank you. Keep watching Physics Star channel, and please do like, share and subscribe to my channel. And whatever the video I am making, please watch it until the end of this, so that you will gain the knowledge about this topic very easily. Gaining the conceptual knowledge is very important while doing the problems. Okay? Thank you.